All right, folks, welcome to my presentation on inSecurity in building automation. This is sort of a talk to kickstart all those of you who haven't been exposed to the building automation industry into how to approach it and how to actually pen test it. Short introduction about myself. Noteworthy items from my past are I was the founder and former head of the Siemens product search, most probably because I happened to be the lead Stuxnet incident handler back at that point in time when it hit. My present is also quite interesting. I'm heading my own ICS security cyber consultancy called inSecurity. I'm a professor for cyber and IT security. I really love to teach security to young people. I'm a science community instructor for ICS, and I run my own conference for ICS security conference. I'm conference chair for ICS CSR. Our CFP is, by the way, currently open. So how did I end up working in building automation industry? Well, because it's interesting, pretty much interesting. Therefore, we put a disclaimer intentionally before this talk. Hacking building control can have serious effects on your health. So I highly recommend not to hack building automation systems without authorization or unless you really know what you're doing, or both of the above. So we had a serious issue in our office with our own building automation control system. So in our office, we do have automated sun shading system like sun blinds. So if the sun is quite intense, shades go down. The problem is that this system is connected to a wind sensor, and the real issue is that this wind sensor is really, really sensitive. So literally, if somebody in the second next building farts, the shades go up again, and we got blinded. And that was the point in time when we decided, okay, we really have to take care of our own building automation control system. So as I guess not many of you have been working in the building automation industry, let's briefly discuss what are the main use cases that you can do with building automation control. Most common one, I guess, still is HVAC, so not having like a direct wiring from the room temperature sensor to the actual heating or cooling unit, but instead of doing it over a bus system, of a bus or a network system, is still a main use case. Very similar, the actual lighting system. So I guess the regular light switches are becoming less and less common and are being replaced through motion detectors, so that there's only light available when there's actually people in the room. By the way, some of you may have noticed already, we put a little challenge in our slide set. So we hit lots and lots of movie quotes in the headlines of our slides. And the first person who sends me an email after this talk with all the correct movies associated that we put into it will get a free beer or any other type of drink. Maybe not a bottle of champagne, but anything else, right? Good. Next use case is, of course, energy management and saving. So, of course, you have the option to switch on specific devices, for instance, when there's cheap energy available. And the last use case that I'd like to mention is actual access control. So it's especially in larger installations, it's quite common to tie the actual door locks to the building automation controller, so you don't need a physical key anymore. But when you add maybe your RFID badge to a sensor, it's being sent a signal to the actual controller, evaluates your authorization, and then a network packet actually unlocks your door or not. So pretty powerful system, building automation control, and as we all know, with great power, there comes great responsibility. And therefore, we said we definitely should take a closer look into the actual state of security functions in building automation. And we pretty much summarized the state of security functions in building automation on the next slide. I'm glad we talked about it. So I'm not kidding you. Basically, the message here is I'm talking about native security functions in building automation control. So I guess we have pretty much the same situations that we had in ICS security in generic industrial control systems, like missing security by design from the very beginning, also in building automation control, because those systems have been designed as maybe locked-down systems, closed systems that never were meant to actually be connected to open networks. Practical issues you run into are, of course, missing authentication at protocol level. Once I'm able to connect to a building automation network over IP or because I'm just connecting directly to the bus, and as long as I speak the right protocol and I'm sending commands, the controller quite likely will be able to read the command and actually carry it out whatever I send it, whatever command I send it. Same issue as well leads to replay and spoofing topics. So the point here is because there's no dedicated security functions like cryptographically supported security functions in the actual building automation control protocols, you have the regular replay and spoofing issue in there as well. So I could just record maybe sensor readings and then replay them at a later point in time to induce wrong control decisions by the building automation controller. Next issue that is quite common is outdated and legacy software. Why is that the case? That, I guess, is the case because if you think about how those systems are being constructed, how those systems are being built, it's about creating an entire building. Once the construction is finished, the actual engineers come along and start to put up their cabling and their controllers and the software. And from that point in time, the building automation control system is a fixed part of the building. And it's most probably not going to be changed for the next 5, 10, 15 years because it is, part of the building. We also took a very brief look at different protocol stacks, and we noted that the devices in building automation control, although are robust and purpose-built on the physical side, but definitely a little more fragile on the network side. So what are scenarios that we are definitely not looking forward with building automation control? So for time constraints, I'm only explaining in this session one dedicated scenario in the white paper and the presentation slides we submitted to Black Hat that you received already, that we added several more scenarios. First scenario would mean that I'm actually trying to go for a physical compromise, and that is pretty easy. The main thing that I would want to go for is an easy physical compromise. So easy target would be to just pull off a motion sensor, a presence detector somewhere along the wall, and those are quite easily reachable, as you've probably seen in this venue as well. What I'm looking out for is, in this case, it's a KNX bus system, just the 2 bus wires that I'm really interested. That's pretty much anything I need. Pull down the sensor, connect 2 wires, and from that point in time with this dongle, with this USB KNX interface, I'm able to talk to the building automation controller, and it will gladly accept whatever I'm sending. What could be a good abuse case? Well, I could try to trigger alarms through sending spoofed messages, for instance, to trigger fire alarms where there's no fire, trigger gas alarms, or any other type of security alarms on the one hand. On the other hand, of course, at the same time, send maybe a lock signal to all the doors, and that pretty much surely would induce panic in the actual building where this is happening. And if you think about that, you have authentication issues here. There is no real authentication in there. I could spoof one sensor at one point in time, another sensor at another point in time, and it would be really, really difficult for the building operator to find out where the actual issue resides. As this is a security conference, we also want to give you a little bit of actionable intelligence or information on how to approach those systems from the pen testing side. So the next slides do cover tools that we've found valuable for doing pen tests of those building automation systems. What's the first step in penetration testing? Of course, it's information gathering. So there's a number of projects that we found valuable. In the end, it depends on what type of control system you're trying to target. If you're looking for KNXnet IP-based systems, that's a protocol that is highly common in Europe and Asia. Luckily, our good old friend Nmap has already Discovery scripts built in. If you're going for backnet IP-based systems, which are highly common in Europe, but as well in the United States, you would, for instance, need to download the backnet discover script that Digital Bond created as part of their project Redpoint. There's HVAC Scanner. HVAC Scanner looks for Honeywell, HVACs, and Tridium Niagara controllers, not by speaking building automation control protocols directly, but more looking for specific fingerprints in the web interfaces of those devices. And one or the other security scanner might also have rather rudimentary fingerprinting modules for building automation control systems as well. If you really want to pen test or abuse a building automation control system, you definitely would want to understand a little more about the protocols. So we have also a very short crash course into those protocols. The KNX protocol comes with different types of physical media. So it could be twisted pair. It could be just two-wire bus, as I had on the photos beforehand. There's an RF subtype of standard. And there's, of course, KNXNet IP, which means that you're able to connect a gateway system between the regular KNX bus and an IP-based network. From the service perspective, there's a number of services that are interesting for security purposes. There are core services which are just there within the standard for locating and identifying corresponding devices. There's configuration services for device management, different services for communication, both for runtime as well as point-to-point communication, and finally, remote diagnostic configuration. So that's just the protocol know-how. What tools could you use? Well, in my company, we have a saying, there's no better hacking tool for an industrial control system than the actual engineering software, so the software that is being used by the original engineers to construct, to program the building automation controller. Same goes for KNX. So the official programming tool for the KNX standard is the ETS, the engineering tool software. It's freely available depending on the size of the installation that you want to engineer. You could either use the free version or it costs you a little bit of money. The interesting part is that many of the functionalities provided in there are also available for security purposes. So what you see on the left side is basically the so-called bus monitoring or group monitoring function, which is the equivalent sort of using Wireshark. However, this is of course not an Ethernet or IP-based system. This is a two-bus wire. And on the left side, you have the source addresses, and on the right side, you do have the destination addresses. So this is very interesting to learn who is talking to whom. So which addresses is being used by the sensors and which addresses is used by the core controller. Most probably the core controller will show up on the destination side most often. Quite interestingly, they built also intentionally a functionality that they would use also for attacks. So up there is a small button that says replay telegrams. So it's really, I guess they built it in for debugging purposes, for testing the installation. But of course, for a security person, that's the only thing you need for actually for monitoring and also for spoofing traffic, like inducing fake sensor readings. You don't need any additional piece of software. So this functionality is good for passive information gathering. There's also an equivalent for active information gathering. You have that on the right side. Here I'm doing a so-called line scan, which allows you to scan specific KNX IP addresses. So probably could say the equivalent of scanning a Class C network, but within KNX, to find out which addresses are actually being used within the system. If you're not into using GUI tools, I definitely would recommend another tool that was created by a group of German security researchers called KNX Map. It's a Python-based implementation, so it has all the functionality for monitoring as well as scanning. It also provides functionality for brute forcing the so-called BCU key, the bus coupling unit key, which is, I think, if I'm not mistaken, just a 32-bit wide key, so not really secure, so it's worthwhile to try to brute force. Then there's group messages, so if you want to send the same command to a number of devices, so for instance, switch every light in the building off, that's probably what you would use the group messaging function for. And if you would want to talk to specific devices APCI functions. Like restarting a device, enable, disable programming, that's pretty much it. Second protocol that I would like to explore with you is BACnet IP. I think BACnet IP is, especially for the US guys in the audience, much more interesting because it's widely used, especially in large-scale installations. BACnet is a manufacturer-independent standard, which means that you have a set of objects for each device with a standard set of properties and services. Some of those services are mandatory, like the read property service, others are not. And again, from a security perspective, you could put the existing services into different groups. So there is one group of services which I would call alarm and event services for ongoing object notification, what's going on, like sending alerts and alarms. There is object access services, which is really there for interacting, like changing or modifying the properties of a specific object within, for instance, a BACnet IP controller. And you also can see that BACnet is really a rather sophisticated protocol because it, for instance, also comes with predefined services for file access and virtual terminal services. So I'm not talking about Telnet, I'm not talking about FTP, but really the BACnet counterparts within the protocol. So really, really powerful. One of the functions that we like most, I guess, is this broadcast management device function, or short BBMD, which provides the capability to register as a foreign device. Why do we find it interesting? Because it's a perfect function to compromise network security, even if you actually did network security right. If you think about, you have a BACnet IP controller on a private network, and for service purposes, somebody requested that the BACnet port is maybe port forwarded to the internet. If this device provides this BBMD function, you can register from the public internet to the service, and from that point in time, you will be able to talk to all the internal building automation controller as if you were in the same internal network. Is that a problem? Unfortunately, yes. Short peek into Shodan, how many BACnet devices do expose this BBMD function on the public internet. Unfortunately, it's nearly 3,000 in the United States alone, and worldwide it is like 15,000, something like that. I'm not sure if you can actually read out. So the example in the middle, it's pretty interesting. I intentionally blacked out the first parts of the public IP address, something with 124, and you see 47808 is the actual BACnet port. If I would connect to this port from the public internet and use this register foreign device function, from that point in time, I would be able to talk to 192.168.3 something. So pretty dangerous function if you expose this over the internet. This slide also details a little bit that you will definitely not only find regular smart homes or building automation systems exposed through BACnet. The top level result is, I think, something like a city parkway access. So it could be something more dangerous in terms of critical infrastructure that, of course, also relies on BACnet. Of course, you could find the results on Shodan yourself, but I intentionally didn't want to expose some of these systems here at the conference. If you look at the BACnet protocol, again, from an attack perspective, we put the existing commands that we found valuable into different groups. For information gathering, you would use read property, read foreign device, the whois commands. If you are more into spoofing specific devices or pieces of information, you would register the IAM routed to network or just the IAM command within BACnet. If you are more into denial of service, so really trying to sabotage building automation controller, then you might want to use, for instance, the router busy to network command, which tells other routers that the BACnet network can't be reached directly, so you could try to redirect traffic. You could try to create the equivalent of a so-called routing loop by by initializing the routing table, or maybe just create a denial of service case through telling a device to reinitialize. And that's what we have on the next slide. Leftmost slide is our regular BACnet core controller. On the right side, we have our Mr. Evil, which is basically a BACnet client that tells the main BACnet controller to please reinitialize, and we send this command every 10 seconds. And by sending this, that's 10 seconds, it's what it takes for the device to actually reboot. If we do this constantly, of course, our legitimate BACnet client is not receiving any information anymore. We found different types of installations, different types of devices. Some devices do require passwords, for instance, for doing this type of service. If that's the case, RTFM, of course, in many cases, the actual password for doing this will be in the manufacturer's documentation. In this case, the password was Jesus. We also took a little bit of a look into actual protocol stability. So we created, I would say, the equivalent of a rather rudimentary BACnet protocol fuzzer, and we used this. This is the example of the most downloaded BACnet implementation from SourceForge. You see on the bottom right that we immediately created segmentation faults just by doing the very first level of APTU fuzzing for BACnet. So I really hope there's not too many devices out there which rely on this protocol implementation. And by the way, today this is still a 0-day. This has not been fixed. So what do we do about this? I really think this presentation should be somewhat of a reminder. I didn't want to call it a wake-up call, that we still have not covered all areas with industrial control systems covered. I guess as always, it's both a technology issue and it's also a people's issue. Technology issue because, obviously, there are still secure by design elements missing in the current state of technology that we find in building automation control. We also still have a people's issue because ASHRAE, responsible for instance, the BACnet standard or the KNX associations, they have put out information how to, I would call it, retrofit security in existing installations. However, we've been doing assessments and we've been doing services, and actually really only few operators and also engineers make use of those recommendations, regardless if they are holistic, so more generic like network architecture or reducing external access points, or even more rare, going for protocol-specific measures like restricting communication paths or relying on security proxies. So I really think it's important that especially the people responsible for creating and engineering and building those systems, the system integrators, learn that they do have a serious responsibility with inSecurity, because otherwise we will be stuck with insecure buildings for the next decades as well. Was that everything? Unfortunately, or maybe happily for you fellow researchers, it's not everything. We explored the security of KNXNet IP and BACnet, but that taken aside, there's many other building automation protocols out there that are being used in the field and that are definitely worthwhile to explore. And with that, end of line, I'm happy to take just maybe 1 or 2 questions if there's time. Other than that, thanks for listening.